this is an electrical network. We have to find the currents through different branches. Just find the values of I1, I2 and I3. I2, I3 and I1. So this can be done by applying Kirchhoff's rules. First of all, Kirchhoff's voltage rule. We know it states that algebraic sum of products of current and resistances in a loop is equal to total EMF of that loop, and the product of current and resistances is equal to potential. So algebraic sum of potentials in a loop is equal to the EMF of the cell in that loop. So here first of all, let us consider this loop A, B, C, A, this loop. So we know the cell included in that loop is this 10 volt cell, and this 10 volt cell that is sending current in this direction. So current is coming as I2, then through this 4 ohm resistor I3, and through this branch this I3 is coming, and we know another current I1 is coming in this direction, that is a different separate current. So that I1 will be mixing with I3 and it will be flowing as I1 plus I3 like that. So what are the potentials? So we know here potential that is equal to I into R for I3, and here I1 plus I3 into 2 products of current and resistances, and here that is I2 into 1. So first of all, check the direction of current coming from that cell. So this is the direction of current. So we can say that flows in the clockwise direction, and the potentials created due to the current flowing in that direction, that can be taken as positive. That's what Kirchhoff's rule is also stated as. For a preferred direction, that is for a preferred direction of current, algebraic sum of products of current and resistance is equal to the EMF of the cell in that loop. That is for a preferred direction of current, the sum of potentials equal to the EMF of that loop, EMF of the cell contained in that loop. So here I2 that is flowing in this way, I3, so we can say all flows in the same direction, clockwise direction. So all these potentials will be taken as positive for I3 plus 2 into I1 plus I3 plus 1 into I2, that is equal to 10 volt, 10. So we can make an equation. So that's why this first equation is made, that is 4I3 plus 2 into I1 plus I3 plus 1 into I2. I2 is equal to EMF. EMF is 10 volt. Then we can simplify. For example, here 2I3 plus 4I3, that will be 6I3. Like that we have simplified. So named as equation number 1. That is 2I1 plus 6I3 plus I2 is equal to 10, equation number 1. Now we are going to apply Kirchhoff's voltage rule to another loop. Suppose we are considering this lower loop A, B, C, A. This lower triangular loop we can consider. Suppose we are naming it as this A, D, C, A, like that. So before that, hope the first equation is very clear. So here the cell is 10 volt and current is flowing in the same direction, and so the potentials due to the currents flowing in the same direction, all potentials have been taken as positive. Now the lower loop, this 10 volt cell, we know this is the direction of current, and from this 10 volt cell, here the direction of current through 1 ohm in this way and downward, this is the direction. So the potentials created due to the current in the same direction has to be taken as positive. So here 1 into I2 plus 4 into I2 minus I3. Now here we have another resistor, and the direction of current is shown in this way. So we know this is clockwise and this is anti-clockwise, or this current, that is the current through 2 ohm resistor downward, we know that is in a direction opposite to the current coming from this 10 volt cell. 10 volt cell is sending current in this direction. So the potentials created due to the current flowing in the same direction, it is taken as positive. That's what we are writing it as. Here we have this I2 into 1. So I2, then this current, that is current from 10 volt cell, and this is creating a potential 4 into I2 minus I3. So I2, that is positive, 4 into I2 minus I3 also positive. Now checking this potential, we know this current is opposite, the direction of that current is opposite to the current coming from this 10 volt cell. So that potential can be taken as negative. That's what we are writing, minus 2 into I1 plus I3 minus I2. That is equal to EMF of that cell. Of course, the EMF of that cell is 10 volt itself. So this is the importance of direction. Direction, that is the statement for a loop taken in definite order, preferred direction of current, not in the direction of the naming of the loop. So the direction, that preferred order, that means the direction of current, the direction of current coming from that cell. So all those potentials should be taken as positive, and if at all there is a current coming in the opposite direction to the current coming from that cell, that should be, means the potential due to that current should be taken as negative. That's what here we are having, minus 2 into I1 plus I3 minus I2, that is equal to EMF. So we got another equation. See, this can be simplified, 4I2 minus 4I3, and here we have minus 2 into I3, and that can be simplified. That is 4I2 minus 4 into minus I3 minus 4I3 minus 2I1 minus 2 into plus I3 minus 2I3 minus 2 into minus I2 plus 2I2 plus I2 is equal to 10. Then the terms can be added and that can be simplified. So we are getting the second equation, minus 2I1 plus this 4I2 plus 2I2, 6I2 plus I2, 7I2, like that. Now let us consider the other loop, that is this loop, this rectangular loop, may be named as B, C, D, E, F, B, like that. So in that loop, we know the cell is having 5 volt, EMF of the cell is 5 volt, and the current coming in this way means that there is, the current is flowing in this way, I1 plus I3 also flowing in this way, and this current means I1 plus I3 reached here, and from that I2 is going through this way, and remaining current I1 plus I3 minus I2 will be coming through this way, and the current is coming from 5 volt cell. So 5 volt is the EMF, and the potentials that is created due to the current coming from that cell, 5 volt cell. So the same direction, so we can thought of this is anti-clockwise direction, all currents, if you are saying so. Anyhow, we know the currents are in the same direction, so all potential should be given the same sign. So I1 plus I3 into 2 plus I1 plus I3 minus I2 into 2, that should be equal to EMF 5 volt. So we can make another equation. So this is the equation. 2 into I1 plus I3 plus 2 into I1 plus I3 minus I2 is equal to EMF. EMF of that loop, that is 5 volt. Then simplifying that, this equation can be simplified, that is 2I1 plus 2I3 plus 2I1 plus 2I3 minus 2I2 is equal to 5. Then again 2I1 plus 2I1, 4I1, like that it can be simplified. So we got to equation 3. We got to 3 equations. First equation, then second equation 1, equation 2 and equation 3. Now comparing 1 and 2, so here 2I1 and minus 2I1. So if you are adding this 1 and 2, I1 terms will be eliminated. So 1 plus 2. So I2 plus 7I2, that is 8I2 is equal to 10 plus 10, that is 20. So value of I2 can be calculated, 20 by 8. So that is 2.5 ampere. So we calculated this current I2. This is labeled as I2. I2 is 2.5 ampere. Now comparing equation 1 and 3. First of all, we are multiplying equation 1 by 2. Equation 1 is multiplied throughout by 2. So 2 into 2I1, 4I1 plus 2 into I2, 2I2 plus 2 into 6I3, that is 12I3, that is equal to 20. That is equation 4. Now compare 4 and 3. Comparing 4 and 3. So in equation 4 we have 4I1 and in equation 3 also 4I1 is there. So we can eliminate I1 terms again. So this equation 4 minus 3, that is I1 terms can be eliminated. 4I1 minus 4I1, then 2I2 minus of minus 2I2, that is 4I2, like that we are getting an equation. 12I3 minus 4I3, that is equal to 8I3, and we got an equation. So 8I3 is equal to 15 minus 4I2. Value of I2 already we have calculated. Substituting the value of I2 in this equation, we can find I3. Now we have got I3 and I2 already we have found. Then substituting the value of I2 and I3 in equation 1. I2 and I3, their values can be substituted in equation 1. Then I1 can be calculated. Equation 1 is 2I1 plus I2 plus 6I3 is equal to 10, and 2I1 is equal to 10 minus I2 minus 6I3. So substitute the value of I2, that is 10 minus I2 is 2.5 minus 6 into I3. I3 is 5 by 8. So we got the value of I1 also. I1 can be calculated. That is, we got 2I1 from this equation, and then I1 can be calculated. So we are able to calculate I1, I2 and I3. Then by knowing the values of I1, I2 and I3, currents through different branches can be determined.